So remember, you have to turn the phone on.
Let's wait a minute because people are coming.
Can you tap on the mic? Does it work? It's disconnection. I don't know why. Can you try again? Yeah, it's working.
Do you need this microphone?
Yeah, it's okay. It's connected to the room and it's wide, so it should be.
Okay, this
You
one.
can put it in your pocket if you want to move. And yeah, I think everything is working. Maybe you can start sharing your screen if you want.
Okay. Yes, you can share the screen.
And yeah.
Okay, we are starting with the next lecture. It will get super interesting. In the previous lectures, you saw basically from the creators of the key packages, SF time, stars. I think you learn about these packages. And we did summer school. We're doing in parallel Python and R, and even Julia this morning and yesterday was lots of Julia. And so what gets really interesting is because in R, of course, you can do things different ways. And then in Python also, but gets very interesting to compare these programming languages and to see which is maybe better at something, and maybe some language is better in everything. I don't know, but that's rarely the case. Usually the case is that, some languages are better in one thing and the other language is better in the other thing. And then in some things, there's no difference. And I'm talking mainly about computational efficiency, usability, diversity of functionality, etc. Also, please know that even in our community, I think if you notice, there is like two home pages for spatial analysis in R. One is r/spatial.org. That's, I think, mainly maintained by Edzer Bebesma. And then there's another one, which is rspatial.org. So hope it's not too confusing. And this one is, I think, maintained mainly by Robert Hymans. And also within R, you see there is packages for the same thing and developed by really experienced spatial analysts. And so there is this Terra package and stars now, and there's quite some overlap between them, but this overlap is fine. And people should have a freedom. It's a creative freedom to do things what they think is the best. And also, of course, Robert and Edzer, they also collaborate on some packages. But what's very interesting now to see how these things perform when somebody does independently. And we have an independent person here, Christoph Diba, and we're very happy that he created these tutorials and he did this diligence of comparing the packages. And Christoph is a PhD student in Poznan, the Faculty of Geography, and he's also a lecturer. He teaches remote sensing, but he programs both in Python and R. So super interested to see now. Let's see the performance. It's from different aspects, and you did all the diligence. But please tell us also about your work a bit. And yes, please keep it to 1.5 hours. So
okay, thank you very much.
There will be questions online. And also today, just to announce, we have a discussion forum in the afternoon, and then we will also put a slider so you can anonymously vote on things and you can give your opinion. So thank you, Christoph.
Thank you.
Your floor is yours.
So my name is Krzysztof Dyba. I'm a PhD student at Adam Mickiewicz University in Poznań, Poland. My research is mainly focused on using remote sensing data from satellites, Sentinel-2, Landsat-A, now 9. And using machine learning algorithms to do classification, regression models. And, I think this is all. And we can start with this topic of workshop today. Go to this repository on GitHub, and you can download whole folder, or you can use only scripts. There are two versions, one for Python, second for R, but at the first we can start with R, the second will be Python. In this repository we have also a README file, so please read this. And I think you should use these notebooks only, but HTML, HTML files are also available, but the most important are notebooks. RMD and Python Jupyter notebook. Show link. This one.
You posted that to MetaMouse, so people don't have to type them images.
But I think some users on YouTube will be interested too. Okay. So this is our studio with our terminal.
Can you please increase the font size?
Okay.
Even 16.
Okay.
Okay, thank you.
So we can start. The topic is spatial processing benchmarking in R, and you should install bench micro benchmark SF star sterile packages. If you didn't do this yet, so just install. And one important thing, this is practical workshop. So I will show how you can make benchmark, show performance of code of functions. And this is not a professional benchmark because first we are using small data set. If you wanna get to know through times, you should use bigger, larger data sets. And secondly, we are, as I can see, we are using laptops. On the laptops, you can have problem with fluctuating CPU frequency, aka throttling, and this is not good equipment to benchmarks. I believe we should use normal PC, not laptops. So do you know what is benchmarking? Benchmarks? So this is simply in definition, this is process of measurement of performance, function performance, code, programs. So you can basically check how fast, what function, what package is the most efficient. And this is all. And do you have these packages installed? Okay. So in R, you can do benchmarks in many ways. You have built-in function system.time, and this is a basic way. Or you can use more advanced approach, like using specialized dedicated packages. This is bench. This package is from our studio team. And second is micro benchmark. And we will check this base function and this bench and micro benchmark packages. So you know the name of this function. To get help in R, you can do this in several ways, like benchmarking. You can use help function. and this in this window you can see documentation for this function. I recommend to read this, but we will test this soon. And you can use a single question mark, question sign, this time, this the same window, or you can use in the double question mark, and this will be this is searching for topics like distributions. And you get many help pages related to distribution topics. Okay. So now we will test this function system time, and we need some function which generate data for us. The most easy way is to just do sampling. So let's one more thing. If you don't like notebooks, you can use just base simple R script and just rewrite code from this to R script. So generate a sequence from 1 to 100. And we can do a sample with replacement. Yeah. And we get samples, some values from this vector from 1 to 100, and get 7 and etc. And now we will test how fast is this function. So as I said before, we can use this function system time. Okay, pretty fast. And we get now results. As you can see, we have 3 values: user, system, elapsed, and we should use this elapsed time because this is sum of the user and system time. So we don't need 3 values, but this last one.
And in Python, is it the same when you measure time?
Yes, they have. Yeah, they have analogics function. But I will say I will talk about when we go to the Python script.
Because for comparison to be fair, you have to really compare exactly the same.
Yeah, exactly.
Same data, looking at exactly the same thing.
You can be about this. You have, for example, function for resampling, but in different packages, this can be implemented in different ways using different algorithms. So if all of the function is the same in the backend, there can be different algorithms. So this is important point too. Yeah, and you know how to select field values from this vector. You can use index like this. I assign result of this system type function to key variable. You can use like this, or write name. Everything is okay for now. Okay, so this is a base function which you can use. As you can see, this is doing only one repetition. So if you want to make many tests, for example, 1000, you have to replicate, and we have another function, but I don't recommend this approach because we have dedicated packages for this. So I think it's better way to use this bench package or micro bench. If you wanna do this test many times, you can use replicate plus system time. Okay, we can check this bench package. There you go to information how to install, features, usage. I will show you. There's some default plots for output. Second one, micro benchmark. This one doesn't have website on package down, but only on CRAN. It's okay. You have manual view. As I said, I recommend using dedicated packages like bench or micro benchmark. This is your decision, but we can now do more complex example. Let's create data frame with 3 columns, X, Y, Z, and generate some data with normal distribution. Okay. And we can try this bench package firstly. There is one awesome feature because you don't have to call to load whole package like library bench. You don't have to do it. You can do it this way. You can call bench double colon, and the function for benchmarking is mark. So you see this pretty nice. And let's see documentation for this. We have different arguments here, but the most important are iteration. This one, iteration, check. If you set check to true, this function will check if outputs are from different function are exactly the same. So this what the Tom said, to compare exactly the some things. And let's test simple function to sum rows in data frame. You can do this in two ways, using function in C, row sums, or using famous apply function from apply family. And do you think their performance will be exactly the same or maybe different? Two different functions doing that something. So you think there will be identical or not timings? Well, let's see. Results here. And what do you think? Minimum time, median time, iteration per seconds. First one is row sums, second is apply. Are they identical? No. Let's see, iteration per second. No, this is faster, the first one. 350 iterations per second, and this is slower, at least slower. Okay, and this was a bench package. Second is micro benchmark. The name of iteration there is times. Check we accept segmentation. Not true false, but character argument.
And these two packages, they don't have anything to do with each other, or they extend each other.
I think they are very similar.
So you do it just to demonstrate. It's not that you need them both. You just want
No. I just show the way what you can use in R. Okay. We are doing exactly the same operation, but you can notice that you have different columns. There are minimum time, first quarter, mean, median, upper quarter, but in bench, so this. Have different columns. Or you can check in this package memory allocation, running garbage collection per seconds, number of iteration, number of garbage collection. Memory.
From all these numbers, the most important is the median.
Yeah, I think so. And iteration per seconds. But someone can be interested in memory footprint, memory allocation. I think this is pretty interesting too, but as you know, Terra is using as the backend C++, and you can follow the memory footprint because this is external pointer. This data are not in R, and this complicated to follow this. Okay, so we have some statistics, and I think it's a better way to not show only the numbers, but make some plots. Do you use ggplot too, or mainly base R? If not, this I can recommend this package. It's very fantastic. Many possibilities to create plots, different kinds, and we can just create a simple box plot from base R, box plot based graphics, but ggplot is more advanced option. Yeah, and growth zones is faster than apply.
And now to understand why is it faster? Because it's a C++.
Yes, exactly. This function row sums is implemented in C, and app is using some R loop, and this is why this is slower. So I talked already about benchmarking, but this is not only the way to measure performance of your code. You can do something like called code profiling, and this is not like function. You can profile a whole entire block of code. So you have, let's say, 5 functions in code of block, and you can check which function is slowest, where is the most overhead, and this is called code profiling. And of course, you can do this in R. There is a dedicated function rprof, from this package. And I wrote here, and I say this for if a package uses external C++ code or structures, data structures, you can profile this. And this is true for most geos and that packages. There are some interesting books. Okay, so go to the benchmarks. We use digital surface model as our TM. There are information about this, resolution, data type. And please load packages. As I said in a previous session, in the SF we have two engines for geometric operation in R, in SF. One is planar, geos, second is spherical, S2. And so we want to compare exactly the same things. On the SF implemented spherical engine, so we have to turn this off, and we use geos by default. So you need to use this line. SF use S2 false. Now let's download data from this URL. There is condition I recommend you, I suggest you to run this, not this whole code block, but this line, this, and this. Yeah, you probably know listing files, so I skip this. And now the main part really start from benchmarking the raster data, raster structures. In stars, you can load data using this function red stars. Just give path to this raster and set this argument proxy as false. As say that you can processing data from disk in stars or from memory. So we want to load every raster into memory, not from disk because this is slower. Okay, do you follow? So now we can see how structure looks like, but let's skip. And of course, we can make a plot. Okay.
How big is the image?
In the context memory size?
Rows and columns.
6,000.
Okay.
90 meters of resolution, 6,000 x 6,000 pixels. And this data type is integer 16. And raster, in raster you can load data using rust function. You have class, dimension, resolution, spatial extent, CRS, source, name of the source. And we can make plot using the same function plot. And some important notes. Please read this. This from documentation of Rust function. So there is difference between packages between stars and Terra. in stars, when you loading data using the function restars, you can set argument proxy to true or false, but in Terra this works in different way. You have to, by default, raster is not loaded into memory, it's only processed for files, so you can process very big files, raster, that can't fit into memory. And we have to load this raster into memory in this function in memory. And we see we didn't load this raster into memory. And if you wanna load this raster into memory like in stars, you have to use this function setValues. Now check, and in memory is raster in memory. We got is true. Okay. So we can now do the benchmark, comparing how fast we can load raster data using stars and Terra. Please use 5 iteration because we don't wanna long processing, check false because we have different structures of rasters, and memory false because we don't wanna follow a memory footprint. Okay. So we have some results, but remember one more. I will say that we have very small data set. If you wanna do professional, full, super benchmarks, you have to use bigger, larger data sets. This is only an example. And from this, we can see that Terra is faster on this example. And I started talking about data types. So this issue is pretty complicated because this raster is integer 16, but let's check this in stars. Yeah. We loaded data into stars, but we get double float data type, not integer 16. And this is why, because all operation done by stars and Terra too, but I will say soon, are the raster are processing double because this is easier for user and developer to get the most complex type, not using integer, byte. This, I think this is most advantage in Python, because in Python you have many data types. You have byte, integer 16, integer 32, float 16, float 32, and many more. But in R we have only integer and double. This raster was I don't remember the size, but yeah, this raster is 70 megabytes, but check its size in R stars. Do you see? Originally, this raster is 70 megabytes as integer 16, but if you load this into R, it's 270 megabytes as double type. Yeah.
And there's absolutely no way to reduce that in RAM.
Yes, you can reduce. In stars you can. you can change the data type, this line,
Okay.
we changing double to integer.
And what's the size then?
I
Okay. How?
yeah, exactly. And check how it looks in Terra. This is very interesting. What do you think? Why we have 1 kilobyte in Terra, but in stars over 200 or 100? What do you think?
Data is not really loaded into R in there, right?
No. I talk about it. Let's see this function in memory. I will use in-memory raster on from Terra, yeah? And it's true. This raster is in memory in Terra. So what is going? Okay, I will explain. So Terra, this is related to what did you say, but Terra loaded data, but external C++ structure, not into R, but data is in memory, but is only in R. This is pointer to C++. Data is in memory, but not exactly in R. But if you check the system, Control Alt Delete and memory usage by system, you will see increase of memory usage. Okay, so next operation we test is cropping raster. Extent, they are exactly the same. Remember, you have two different classes, so it's like different outputs. This is input bounding box extent, spatial extent, and we will crop this to the smaller extent. And we have to define. This is a simple function st box and extend in Terra. Make some plot.
Which is faster for plotting?
SF. I create issue on Terra, and I had a conversation with Robert, and he's about this, but didn't fix it yet. But through this package using as backend basic graphics from R. One important thing. You don't print all the pixels, but on the backend is doing downsampling. Okay. If you want to crop raster, there are two simple functions: st crop in stars, crop in Terra. Generally, you have equivalents from stars in Terra, but in stars you must add ast as prefix. We cropped. We can see the new extent. Okay, it's the benchmark. And in this operation, in this case, the stars is faster, CP faster. This first one.
But comparable, so not a big difference.
Yeah, because we have a small data set, but I can show you. In this case, I use satellite stem from Landsat A and the server, not laptop. And okay, this slightly different, but you probably used raster before, and you can see how slow it was. Raster, this old package. Now everyone is using Terra.
Can you do control plus? Yeah. This IOX array
From Python. Is
Python.
yeah, this is fast because they are using in place replacement. They don't create new object but replace in values in memory. So this is why this is the fastest option. But did you use raster before? So you should stop and move on to the Terra because it's much faster and memory efficient. Okay. And the last task in this raster section is downsampling. The first comment is how we can check resolution in stars. This is pretty complicated, but I hope that there will be improve this in future. In Terra, to get raster resolution, just type res and they are the same. Resampling, especially downsampling, but the upsampling too is a little bit complicated because you have to specify a new object, new raster with new extent. And this can be done this way. dx, dy is the new resolution. You have to fill this new raster with new extent, with new resolution, and use this function stwarp. Yeah, and we can see now we have smaller resolution. In Terra, this looks exactly the same. We have to specify resolution 2, CRS, extent. This is raster with destination. This is downsampled raster. Yeah, and we see resolution is this.
So SF uses GDAL to do that. Makes sense. And Terra has its own
No, both using stars and Terra using both.
GDAL.
Yeah, exactly. But stars in this example is not is doing strange thing because, as you can see, stars is creating new files. So you have not only overhead from resampling, downsampling, but you have count also overhead from creating new file. Opposite, Terra is only processing data in memory, so that's why Terra is fast in this operation. But benchmark, yeah, you can see stars method average use dal true, and Terra is doing this by default. Rm function is a function which remove object because we don't need. If you have a gigabytes of RAM, I recommend you use this object we created before because they are using our memory. And you see, Terra is 3 times faster than stars because stars is creating the corral file with output. Yeah, this is not necessary, and this is why Terra is faster. And this you have also different ways to do resampling, aggregating, but let's skip this. And there is exercise, but we don't have time. You can do this after workshop and write to me, or we can meet and talk about this. Here I give some ideas how you can do this. Also, let's skip. And now second part about vector data. You can restart this notebook if you don't have memory, and I will do this. And this part we use not real data before we use data from satellite. In this part we can use synthetical data, so data generated by us. This is how we can generate data, and this number of points. Generating data from stochastic distribution is stochastic tool, so we wanna make the results reproducible. So we need to set seed of randomness this way. Okay. Yeah, and we generated simple feature data frame with points in projected CRS. And to save this data to file, we can use this function write SF. Let's do it. Okay. Yeah, let's do the same operation which we do for raster data. So data reading. This is in star. It was read stars. To read vector data is read SF. In Terra we have RAS for raster reading. For vector reading is vect. Yeah, and benchmark. Yeah. Terra is twice faster for reading vector data. Next operation, very popular in GIS, creating buffers. Yeah, too simple.
Why would Terra be faster reading vector data?
The same reason, because vector data is kept in external C++ structure, and you don't have making a conversation for an object in SF is our data frame or list. SF data frame table, and Terra is working different way. You have just external structure in C++. You don't need to read the data to R. To function st buffer from SF buffer in Terra. Yeah, you can see the names are pretty the same. We have to define distance or width. This is the same of buffers, and number of segments to create the cycle. Let's set to 5 because we wanna fast check. Yeah, as input we have points. Now we have buffers, polygons. In SF, polygon, 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 in Terra polygons. This is visualization. We use only 5 segments to create a quarter of this cycle. So you see this not good roundness. Pretty okay, and the benchmark. Okay, results. And please remember the timings, because if we compare with GeoPandas is much faster. I don't know why, but GeoPandas is in this example is much faster, over twice. And last operation is calculating this distances between points. Yeah. Just we have to select a small sample because this is very expensive operation and we don't want to host time and memory. So let's select on the 3000. Yeah, and there is functioning. Yeah, this is the same as the distance in terms of distance, but we have to call as matrix to get matrix from distances. Yeah, and we have matrix nxn of distances. This is the last benchmark in R. Yeah, and Terra is faster too. And this is all. There is one more exercise, but as said before, let's do it after this workshop, and we can go to the Python part. Any questions for our part?
The general recommendation is to use the Terra.
Yeah, exactly. I prefer Terra for vector data, raster data, but not only. I have a project in stars too. So if you're looking for best performance, best memory management, I think you should use Terra. Also, you can see my benchmark is in this repository. Raster benchmark. This is just go to the OGH2022 repository and this line. You can see more complex, more advanced benchmark for vector and raster data, and I use in this benchmark more packages. Okay, so let's go to the Python. I use Miniconda, so I have to go to this terminal console and right-click there. Okay. So let's start doing some benchmarks in Python using Python packages. We will use raster.io. This is the most popular package for processing raster data in Python. For vector data, Python users use GeoPandas. Okay. Tom, did you ask about alternative function of system time in Python? So they have timed library and the class for making benchmarks to time some function is timer class. Can do this in this way. Yeah. Library timed in this class. Using a question mark, question sign, you can get help, or using a help function. It's exactly the same in R. This is a window with help to this class timer. Yeah, just check this sampling performance in Python. Yeah. This from library random function choice. Range is specified in this way. Number of values using k argument. Yes, in R we have system time function. In Python, this is timer without repeat. Yeah. In as text, you should write function to benchmark, specify environment, globals, number of how many times will this function will be executed, and repeat. This is how many benchmark tests will you do. So function executions set to 1 and benchmark times 5, like we did in R. Okay. To calculate some statistic like median, average, minimum, maximum, we have to import library. This is statistics library, and you can use minimum, standard deviation. In R, this function is built in to base R. In Python, you have to import statistics library. And Jupyter Notebook have very interesting feature because you don't have to use this in this way. You can use a % sign and just write time it, and this will be timing one function, or you can time entire cell. But in this case, write to % size. But yeah, repeats 5, number of function execution 1, and the function. And this is all. Yeah, this is only benchmark one function. This benchmark whole cell exercise, but skip this. Data source is exactly the same. You downloaded this is in R. You can use this as well, but if you didn't, there is a code block for how you can do it in Python. Yeah, but URL is exactly the same. Okay, and benchmarks, we use raster.io library. As I said, it's most popular in Python, but they are using RioXRI. Raster.io is using as backend NumPy, but RioXRI is using uses XRI. But only check this one. And data loading using raster.io is more complicated in using R packages, because you have to open connection to file, load metadata, load raster values, and finally close this connection to file. So as you can see, this more complicated. And of course, this is only you can use this if you're loading raster with one band with multiple bands. But if you have these bands saved in separate files, you have to write loop by yourself. Yeah. In R, this is automatic. In R, you can just give object with last files, and this will be automatically loaded into memory. In Python, this is complicated a bit. Yeah, so load this library, put this connection, get metadata, read values to matrix, to NumPy, and close the connection to file. Okay, and run. Yeah, and here we go. we have GeoTIFF, integer 16. As I recall, in R it was double, in Terra and stars. In stars we can convert this for integer, but still was pretty high this size of this file. Yeah, and we can access to values this way using indexing. If you follow me, you can change these indexes and get another extent, like in this case, we can see values are masked, so we don't have values, there are NA. But if we change indexes to some center of this image, we can see now values 29 and etc. Moreover, we can check the size of this file in memory. Yeah, it's 68 megabytes. In array it was over 200 megabytes, or if integer over 100. In Python this is exactly 68. Yeah, and like in R, create a plot. For prepare a plot in raster.io, we need this module and this function. And one important thing, you need to specify parameters of affine transformation, because if you don't do it, you get these coordinates in pixel dimensions. So 1, 2, from 1 to 6,000. Now, if you use parameters of affine transformation, we have this coordinates in degrees from 10 to 50. Yeah, and let's do the benchmark using this double percent sign. Next operation is cropping, like we did before. We need to import this module, mask module, and another library with to create some shapes. You can do this in raster.io. You need different next library with to processing geometries. This is Chapelle. Yeah, and we define extent, aka box. Extent was R. Here,
Can you increase the font also, please?
I'm not sure.
The view, maybe.
Okay.
But just control plus plus.
Oh, okay. Yeah.
Yeah, great, thank you.
Thank you. Yeah, let's run this. They are values of extent of box. Take care of the order. And another thing is they can be as box. They must be a list. And in this function mask, you need to set crop arguments to true. We got cropped raster, but this in pixel coordinate system, not geography, from 0 to. Yeah, and benchmark. Okay. Probably I should prepare a table where we can put this our result of benchmarks, but we are using laptops, so I don't think they are properly correct done. So I recommend you to check this repositories with better benchmarks, with more data, raster benchmark. And okay. Oh, next operation of sampling like R. This is working in different way in R because in R we had data loaded into memory in raster IO. As you can see, you are reading data, but you don't read this in full resolution in let's say 10 pixel, but this is the data is loaded after resampling, so this will be faster than in R. Yeah, but you have to specify resolution, number of pixels in high, width. Yeah, open raster tool, read metadata, do resampling, and one more thing in R. If you do some special operation, everything is updated. I mean, extent, resolution is automatically updated. In Python, you have in raster IO, you have to do this by yourself. Yeah. You have recalculate parameters of resolution in this way. And of course, close connection to file. Yeah, and we can check the resolution of output. Yeah, it's small. 500x500. Oh, I talking about this. This first parameters of affine transformation. You can see resolution. We updated this. And now we have 0.01 resolution, pixel resolution. Yeah. We did it by hand. Yeah, this is not automatic operation. Yeah, benchmark. Yeah, one more task for you, but we don't have time. And vector data. Yeah, GeoPandas is, I think this is only my opinion, but it's very similar to SF. If you using in RSF, I think the transition to GeoPandas will be for you very easy. Yeah, in R we create synthetical data set. In Python we can do this, but if you will check some design function, for example, generating samples for some distribution, normal distribution, and see in our, for example, seed number 1 and our Python seed number 1, you get different results because generator of numbers are different implemented, and if you use the same seed values in R and Python, you get different results. But there is one prepared packages. This link under the word ways. You can check this, how you can solve this problem. So this is why we will use data generated in R. But there is a sample code how you can do this in Python, but let's skip this. And as you can see, we use data generated from R. to compare exactly the same data sets. Yeah, let's read this file. We have come with geometry, it's point coordinates. As you remember, in R for raster and Terra packages, we have classes spat vector, spat raster, or stars, or SF. In GeoPandas, probably it's class 2, but you have to print CRS separately, extend print separately. In R, it was automatically done. Yeah. Yeah, and benchmark. Pretty slow, yeah. So let's how this looks, and another data set. Do you see the difference? Time of loading Go package. Terra, SF, GeoPandas. GeoPandas is pretty slow, but there is a solution for this.
30 seconds.
Yeah,
Every time you need to load it, 30 seconds.
yeah, this is true, but there is solution. There is another package for fast vectorized loading data in GeoPandas by
They are working on that. So they want to improve the speed.
Yeah, this if you use this, loading and writing data will be much faster. They state, do you see? If you use this library by OGR.io, this will be much faster. So don't worry. Okay. Creating buffers. Yeah, simple method for object vector, buffer, number of objects, resolution. This is the same what number of segments in our packages. Okay, do plot and benchmark. Yeah, okay. And this is very interesting thing. Please look at this. I don't know, but SF and Terra are twice slower comparing to GeoPandas and pure geos information bindings from R to geos. So I don't know what is the reason, but we have to talk with Edzer and Robert. Yeah. As you can see, GeoPandas is twice faster. Personally, for Terra, I would expect that this will be some speed as GeoPandas, but it isn't. I don't know why. Okay. And last one. Yeah, like in Terra, function distance, but this work quite different because you need to specify one object and second. And if you do this in R, you will get distance matrix, but not in GeoPandas. You will get everything everywhere 0 because this is calculating distances like interval between first object in one, first object in B, and etc. Yeah, it's pairwise, but not like matrix, but two lists. And we have to do this in a different way. In R, do you know apply function? Yeah, we use this on the start of our part, but exactly the same. Of course, we can write loop in Python, but we used R before, so we can do this similar using this apply function. Yeah. Of course, use the smaller data sets on the sample. We need to write a whole function, but using lambda expression in R, this is available too. We can run this. Now we have matrix with distances between points. Benchmark is function time it. Okay. Above 4 seconds, over 4 seconds. And let's see this benchmark. Yeah, in this case, Terra and SF are faster too. I don't know, there is some overhead from Python, and I think Geos is has some is slower because Terra, I think, uses internal C++ code, SF using dist function from R, and you can see GeoPandas is a little slower. Yeah, Geos, yeah, to this R implementation, R Binix for Geos. Yeah, it was the last benchmark, this exercise, but I think this is pretty interesting exercise because you are combined using raster data and vector, how you can sample raster values using geometry layer, point layer, using raster IO and GeoPandas, how we can do it. Yeah. Here there is example code, but you should benchmark this as homework. So last 10 minutes, do you have any questions? Should I return to some code? Okay.
First one, it's not my question. There was somebody on Twitter yesterday who asked about your benchmark visualization. So you've got those graphs for both vector and raster benchmarks, and you represent each project and each library as a dot.
Mhm.
Have you tried to repeat the same calculations many times, and instead of using dots, try to show what's the variance in the result? So maybe one package is very fast, but sometimes it's not.
Yeah, I know what are you talking about. Usually the first time is the slowest, next time are similar, and the difference between them are very low. So yeah, this is very good idea to create viewing plots with more points or even more benchmarks. But there is one very some benchmark from data table package. You know probably that, yeah. And they are using only two runs, first run and second run, and they are create visualization bar plots, and you can see this longer bar is first run, shorter is second run, I think. Yeah, first time and second run.
The first one, and the second one was, can you maybe explain to all of us your benchmark setup? Because here during the workshop show how we can benchmark parts of code, but you already are doing that for larger data. So can you explain the setup very quickly?
Okay, no, it's fine. So I test more packages. There is a list with all packages tested. You have tips how to reproduce this benchmark data set. I use one Landsat a satellite scan, 10 bands, resolution, number of pixels. Here is ID of this scan, and two links to download this to reproduce this results. And the most important is PC configuration. You can see this here. And what more? And codes, yeah. Every script is available, so I think everyone can repeat this test. Do you have more question about setup?
Yeah, I have a specific question, like how you gather all of the results. So do you call all of the functions from command line, or do you call them directly from R and Python and gather the results and compare them? How you gather all of the results with this one flow?
So generally, I prepared bash script. Every script is run separately from R and Python, not using RStudio, Jupyter notebooks, but just plain console or Python. And next, I have one prepared notebook with calculating the statistics, aggregation, summary statistics. This is that file. Yeah, and when I run benchmark, let's say cropping from raster, I'm saving a result of benchmark to object, and finally I say from every benchmark I save CSV file with results. Next, as I show, I read this all files CSV. And in this script, in this our notebook, yeah, these lines, yeah, and making plots, just yeah. And times are aggregated using median. I'm not sure I explained this well, but you can ask, yeah, if you have more. Yes, another question?
What would you still like to add for benchmarking? What would you still like to compare?
Oh, I have many ideas. I think in my previous work, I used only one data set with integer data type. I think I could use bigger data set, save as double, check not only processing files for memory, but also from disk. Yeah, this is done by default in R, not in Python, I think. Next thing is I put my results on Twitter, and some people give me some tips, advice to compare not only Python and R, but also include Julia, C++, GIS software like ArcGIS, Quantum GIS, Grass, Saga. So I think there is many great ideas, but someone have to do it.
There's GraphGIS, I think that would be super interesting. Let's see if there's a change with GraphGIS.
We can talk about Julia because we have some.
C++, I think like there is actually C++. I mean, R is maybe C++, right? So you don't need to extend.
Yeah.
And what about, like, for example, I'm interested in prediction, like if it's a random forest model, and you want to see the prediction time, because that's actually costs the most.
I think the most.
Overlay and prediction costs the most, because the rest use GDOT.
I think in the most consuming time is from machine learning algorithms, not from assigning values to map, because everything is a vector, yeah. So,
okay.
So I think you should choose good, fast machine learning algorithm.
But if there's a space that are made in C++, so they're compiled, same library compiled for R and Python, like HG.
I did some geomorphologic mapping using random forest, XGBoost, SVM, and I was surprised because do you know Ranger?
Yes.
Yeah, and I thought wrongly this is the fastest to make prediction, but I was wrong. I will solve issue. So I remember. Okay. Yeah, I was very surprised from these timings. I will make this. Yeah, I compared this random forest written in R and this super fast package Ranger written in C++, and just see this prediction times. Yeah.
So the Ranger is much faster.
No, it's slower, 1 minute.
This was minute, okay.
Yeah.
I was thinking 1:14.
Okay, yeah. But yeah, you can see prediction is not very much optimized. We should do some profiling, so also some other issues. Yeah. So I think you should in your work make good choice using some optimized packages. Yeah. Ranger is very fast for training model, but as you can see, it's slow for prediction. And I think that assigning values to map vector is pretty fast. The most overhead is from making prediction like this. Yeah, it's only 1 million values, so maps are much more bigger. Yeah, so this I think important thing.
What does it say at the bottom? Let's see.
Oh, I don't remember. I can send you this link for this issue.
It's
But-
not a conversion from R to C++, yeah.
Yeah.
Okay.
Yeah, interesting. Yeah,
Yeah.
I was surprised when I checked this.
Send it please on the MetaMask.
Okay. Yeah.
We are slowly towards the end. So let's try to summarize. Looks like for many standard operation, Terra is really cutting edge.
Yeah, I think if you're still using raster, you should definitely go to the Terra. And moreover, I think this is, if you're using Python, you still should use Python. If you use R, you still should use R. Yeah,
But you nevertheless you find with the GeoPandas that you gain a lot on.
yeah, using but second one fine generally GeoPandas using base Python is slow too, but developers created something called PyGeoS, and this library is also vectorized. So if you have installed this package, you will see big speed up. Yeah, if you don't have this library, GeoPandas will be slow. This important.
So let's say somebody is an R user and does like 80% of code is in R, they're happy, but they have few steps where they know that it's like 2-4 times faster in Python. So a good thing will be to then incorporate Python into R, that process, just to run that and come and then get the result back.
I'm not sure. Are you talking about raster data or vector data?
Both. But
Because
like imagine if I need to run something 1 hour, and now I know if I do GeoPandas, it's done in 12 minutes.
yeah,
Then I want to change my code to save that 40 minutes. I don't know.
I think if you are do some huge projects, you shouldn't use R or Python, but focus on C++.
That's what you think. Okay. That's an easy way. But let's say if I see that many of these packages are really cutting edge. They're like using C++ in the back, right?
Yeah.
So we can, if we feel comfortable programming in R, you could just
Yeah.
make a 1 R
Stick to
code
R or Python.
and then just call the bash or Python in the step where you wait for 1 hour and it's fast.
Yeah.
Then you could incorporate it probably, because if you just need to get one step in the whole process and it takes 1 hour and
But I think it could be problematic in private sector, because in project where I participate, we stick to the one environment. You couldn't mix if project managers use Python, our project have to be in Python. Yeah, so this.
But if you use Docker, you make sure it's all tidy, so it shouldn't be a problem.
Yeah.
Do you use Python in R or
Yeah, I'm using both.
use both? Okay. And what is your experience?
Personally, I prefer R, but Python is much popular. So yeah, if team was using before, so nobody will be switching all project to the R. So you have just to learn Python and code.
Okay. Well, that's for me. Or
Yeah.
just use Bash, just program in Bash, and then call R, Python, Julia, whatever.
Yeah.
To get everything out.
I can say about one interesting thing, because we have in R and Python not only frameworks like SF, GeoPandas, but we have low language bindings like this is a package from Dewey Dunnington. That's from him. Yeah, he's very famous on. He creates S2 geos, yeah. So you can use this like bindings to C++ from R. And you remember SF as backend is using table or data frame, but yeah, we can use data table. Yeah, this is written in C. No, not this one. No, this one. Yeah, written in C, and this is very fast. And as backend, you don't have to use data frame, but use this data table. And I have some interesting blog posts. Or if you would like to get some performance, yeah, you can use data table or collapse. Yeah. There is one interesting post, how to integrate geos, data table, SF, and this is pretty fast. Of course, only for vector data. Yeah. Okay, so I think I can finish. Thank you very much.